Your app's AI feature works perfectly in the office. Then the user opens it on an airplane, the cloud request times out, and the intelligent assistant becomes a spinning circle with excellent branding. Apple's foundation models update points toward a better architecture. In the 2026 platform release, developers can adopt a language model protocol that works with the foundation models framework and can represent either an on-device model or a server model. That turns local versus cloud from a permanent argument into a routing decision. Local models have obvious advantages. They can work without a network. Sensitive content may remain on the device. Latency avoids a round trip. The app is not paying an API bill for every small transformation. Cloud models have different advantages. They can be larger, update independently of the operating system, use server-side tools and data, and handle tasks beyond the local model's capability. One protocol does not erase those differences. It gives the app a common boundary around them. Imagine a writing application with 3 AI actions. The first rewrites a selected paragraph in a friendlier tone. The second extracts dates and tasks from private notes. The third researches unfamiliar technical claims and produces a cited report. The first 2 are strong local candidates. They use content already on the device, benefit from low latency, and can provide value offline. The research task needs network sources and more complex tools. Route it to a server model after the user understands what data will leave the device. The application should not scatter model-specific calls throughout every view. Put a model router behind one domain interface. The request describes the job, required capabilities, privacy class, maximum latency, and whether offline completion is mandatory. The router chooses an eligible model. The result returns structured content plus metadata showing which route was used, whether data left the device, and which failure occurred. Apple's newer error types matter here. A model-specific failure is different from a session failure, which is different from no eligible model being available. The interface can respond honestly instead of translating every problem into "please try again." Now consider fallback. If the cloud is unavailable, some tasks can fall back to a smaller local result. A summary might be shorter, but still useful. Other tasks must not silently fall back. If the user requested cited web research, a local model without sources cannot produce an equivalent answer. The app should explain that the required route is unavailable. Capability fallback must preserve the contract, not merely return text. Privacy needs the same honesty. Label each task by data sensitivity. Local processing can be preferred for personal notes, drafts, health information, or private messages. If a server route is needed, minimize the content sent and make the boundary visible. Do not market local intelligence while quietly uploading the hard questions. The language model protocol also creates a testing challenge. Apple explicitly warns that the on-device system model changes when users update to iOS 27, iPadOS 27, macOS 27, or visionOS 27 and tells developers to test prompts against the new model. That means an on-device model is not a frozen library inside your app bundle. The same prompt may behave differently after an operating system update. A schema may fail more often. A safety behavior may change. A carefully tuned instruction may become less reliable. Build a prompt evaluation suite. Store representative inputs, expected structured fields, prohibited outputs, and quality rubrics. Run it on every supported operating system and device class. Run it again when the server model changes. Do not assert exact pros. Test properties. Did every date preserve its source text? Did the structured output decode? Did the rewrite retain names and numbers? Did the model avoid sending a local-only task to the network? Did an unavailable capability produce the correct user-facing state? Also, test resources on device inference competes for memory, power, and thermal budget. A response that feels instant on a high-end phone may feel very different on the oldest supported device. Route design should include device capability and current conditions instead of assuming local always means fast. Cloud cost deserves a budget. Set limits per feature. Cache only when policy allows and avoid sending the same giant context repeatedly. The common protocol should make cost observable, not invisible. Make routing visible in development builds. Log the requested capability. Selected model fallback reason, elapsed time, and privacy class. Add a test mode that forces local, forces cloud, and simulates each route being unavailable. Otherwise, the fallback path will receive its first serious test when a provider is already down, which is the architectural equivalent of learning where the fire exit is during the fire. Give users a preference where the trade-off is genuinely theirs. Some may choose local-only processing even if a feature becomes weaker. Others may opt into a cloud route for better quality. The interface should describe the consequence in plain language instead of making privacy a scavenger hunt through settings. Structured generation is especially useful at the boundary. Views should receive typed data rather than parsing a paragraph with regular expressions and optimism. If the model must return tasks, define task fields. If it must classify a request, define the allowed categories. Validate before updating application state. Then keep tool use separate from generation. A model can propose an event, but the calendar action should pass through ordinary application permissions and confirmation. Local inference does not grant local authority. The important Xcode 27 story is therefore not that every app can sprinkle AI into a menu. It is that model choice can become an explicit architecture layer. Route private, offline, low latency transformations to the device, route tasks needing larger capability, fresh information, or server tools to the cloud. Test both routes as products with different failure modes and show the user which boundary was crossed. One protocol can simplify the code. Good routing is what makes that simplicity trustworthy.